Okay, on your previous video, I left the notes exactly like this, where we have a little formula to find the length of a vertical segment, which on a vertical segment, remember, which would follow a vertical line, any point on a vertical line, the x-coordinates are always going to be the same. So when we find the segment, all we do is subtract, we find the difference, meaning subtraction, find the difference between the y-coordinates. Okay, whereas on a horizontal segment, right, something like this, at any point on that line is going to have the exact same y-coordinate, so we just find the difference in the x-coordinates to find length. And then if our length comes up to be negative, depending on how we set up how we found our length, then we just have to understand that distance is always positive, and the absolute value will take care of that for us. Okay? So now let's put those two thoughts together, and let's come up with how to find the distance of a horizontal translation. So let's say that we have 2 points. So let's put a point, let's say, well, I'll grab a tool here. Let's put a point right here and a point, say, right here. I'm kind of curious, how long of a segment is it, or how long of a translation would that be? And let's say, just for a visual, this point translated to this point. Okay, so to find the length of a translation in the components, we have to look at the components. How far vertically did our segment move, and then how far horizontally did our segment move? Well, if this is our little formula here for the length of a vertical segment, then doesn't this segment then, whatever the y-coordinates happen to be, they're going to follow this rule, right? And I'll show you we'll find these coordinates and I'll show you this. And then the length of the horizontal segment here, doesn't that just take our x-coordinates of these points? Let's see, I want this alone here. So this little rule then is going to find the length of our horizontal segment, right? So, can't we could think of this because of the vertical and the perpendicular relationship. These are perpendicular, right? Therefore, we got a Pythagorean theorem relationship that'll tell us the length of this segment, which we normally call c, right? If we think a squared plus b squared is going to equal c squared, then this is how we do it, because this is our general rule of the length of a vertical segment. This is our general rule for the length of a horizontal segment. So if we can take the coordinates and find this length and square it, add it to the length of this squared, right? Then that's going to equal c squared, and we can actually find out how long this is by taking the square root of these two sides squared, added up together. Okay, so let's do an example with the actual points. This point here, we have to go from the origin, and we have to go to the right one up 2. So this location is 1, 2. Okay, this point over here, it looks like from the origin we have to go over 1, 2, 3, 4, 5, 6, 7, and then we have to go down 1, 2, 3. So this location's at 7, negative 3. Okay, so the length of this vertical segment, all we have to do is subtract the y-coordinates, right, of this point, and we probably should find out what this point is, because it is the end point of this vertical segment and also the end point of this horizontal segment, right? And the location of this point looks like it's at 1, negative 3. So this is at 1, negative 3. Alright, so the length of this vertical segment, just subtract the y-coordinates. 2 minus the negative 3 is really like 2 plus 3, so this length would be 5. Then this length here, if we subtract our x-coordinates, we could take 1 minus 7. Did I count that right? 1, 2, 3, 4, 5, 6, 7. Yep. Yeah, so we subtract our x-coordinates. 1, 2, 3, 4, 5. Yep. And we're going to get 7 minus 1, or 1 minus 7. 1 minus 7 is negative 6, but we have to remember distance is positive. This has a length of 6. So Pythagorean's theorem says take our side of 5 and square it, so we get 25. That's our a squared. Plus our other leg squared. 6 squared is 36. That's going to equal our c squared, our hypotenuse squared. So if we add up our two areas of our squares here, 25 and 36, we get 61. And that's going to equal c squared. So then c automatically is just going to be the square root of both sides. So c is actually just going to be the square root of, say, 61. And we'll leave our answers as exact. Okay, so this is the exact length that this translation is. Okay, so let's generalize this now. I'm going to take this rule, and let's actually create a rule, what we're going to call is the distance formula, to find the distance of any diagonal translation. Okay, so let me see if I can clarify what I just said there. So I think I copied it. Here is our distance formula, and we're going to derive where that comes from. Oops, I need to go back and make sure that I copy these. Copy and paste. Okay. So let's get rid of the grid. Let's just say that we have 2 points, and we don't really care exactly. We're going to generalize their location. Okay. So I'm going to say that we have some point, say here. Whoops. Some point here and some point, say here. So we want to know how long of a segment that is, right? So if we're thinking translations, what we have to figure out is the vertical component and the horizontal component to get from one point to the next. We know that this is a perpendicular relationship, so that's always going to form a right triangle. Well, the length of our vertical segment, we already said, and I'll make this stand out a little bit better here. Let's make it red. It's going to be the difference in our y-coordinates. Take the absolute value of it so that we guarantee the positive distance. The length of this horizontal segment, we said, was take the x-coordinates, right? So let's say that this point here has the x-coordinate, and I'm going to put a 1 because it's the first point I'm talking about, and it has some general y-coordinate, say 1. So this point, if we generalize, it's got some x-coordinate, some y-coordinate, right? Well, here's another point with some different coordinates. So I'm going to say x sub 2 and x sub 1, right? This location, if we wanted to, we could figure out where it's at. It's got the same, since it's horizontal, it's got the same y-coordinate as this point, right? So this is like y1. And since it's vertical, it has the same x-coordinate here, say x2. So if you look at the coordinate points of this, it's the same x-coordinate as this point, same y-coordinate as this point, so this is where it's at. And then the length, I hope it makes sense, subtract our x-coordinates, x2 minus x1 or x1 minus x2. And then here, oh, this is a y2, my bad. This is y2. So this point down here would just be subtracting our y-coordinates, y2 minus y1, or y1 minus y2, doesn't matter. Okay, so Pythagorean's theorem says, all right, we're going to call this A then, and we're going to call this B then, and this is still our C, right? So if we square A squared means that we have to square this expression in here, okay? So what we have to do then is take the absolute value of x1 minus x2, that's the length of that horizontal segment, squared, that's Pythagorean's theorem, plus the length of this vertical segment, which we're saying is the absolute value of y1 minus y2 squared. That's going to equal c squared. So to get c, what we have to do is take the square root, and what we do to one side, we do to the other side, right? The square root and the square inverse operation, so we're just going to get c, the hypotenuse, that distance. It's going to equal this big long thing here, right? So absolute value guarantees positive length. Also, when you square a number, you're always going to get a positive value out. So that's why in our distance formula, the absolute values kind of go away, and we just use parentheses. So what we get then is the distance, instead of c, let's call it d for distance, right? The length of the segment, or the distance that a point is going to translate, is related to Pythagorean's theorem, and it's this distance formula. You're going to take the square root of the length of the horizontal segment squared plus the length of the vertical segment squared. Okay, so let's look at an example here. What is the length of a segment that has the endpoints that's going to be at 2, -4, and -3, 3? Let's use our distance rule to actually find the length of this segment, and then I'll show it to you on a grid and see if it makes sense. Okay, so all that we have to do with our distance formula is identify the x-coordinate of one of our points. Maybe I'll call this, say, x1. That makes this the x-coordinate of our other point, say, x2. Therefore, this would be like y1, the y-coordinate of our first point, and then this would be like y2, right? And now it just becomes substitution in our formula. So the distance, or the length of this segment, or the distance between those 2 points, is going to be the square root of x1, which we're calling 2. We're going to subtract the other x coordinate, so minus -3 squared, due to Pythagorean's theorem, plus we're going to take y1, which we're calling -4, and we're going to subtract off the other y coordinate 3 and square it, just plugging in our points based off of what we identified. So now we have to simplify within our parentheses due to order of operations. 2 minus -3, add the opposite. We actually get 5. This becomes 5. And we can square 5, so 5 squared is 25, plus -4 minus 3 is -7. And when you square a -7, -7 times -7, we get a positive 49. Remember, squaring, we always get a positive number out. So now let's clean up our addition here. So we're actually taking the square root of 25 plus 49, which is 74. 74 is not a perfect square, so this will be an approximation, a decimal. And if we wanted to find out what it is, this is exact, by the way. So if I ask for an exact answer, you give the square root. But if we want to know about what that is, we grab our calculator. Oh no, where's my... Well, my Wabbit's not working. Okay, I'm going to grab this calculator, and we're just going to take the square root of 74. So square root is right here. So it looks like about 8.6. Okay, let's just plot this these points on a coordinate grid and see if 8.6 makes sense to us. Okay, so I'm going to grab a coordinate plane here and make this a little bigger. I'm going to put a point at 2, -4. So 2, go over 2, down 4. And then we have a point at -3. 1, 2, 3, and up 3. So there's our points. So therefore, we're finding the length of this segment. And a good way to verify to see if we're right, let's use a circle tool that's centered maybe at this point and goes out to this point, so that segment's a radius. And notice now when we look at horizontal, here's 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more, right? If I would have done this a little bit better, then we go 8.5. So you can see that that length, which is the same as this length, radii, can help us understand segment length, right? It's about that 8.6 that we found. Alright, so that is an example of using the distance formula. Good luck on your assignment.